What is the big deal with this, with the box of donuts? I mean, the black hole picture. Why do people care?
It's a vindication of, there are two scientists that I consider personal demigods almost.
Okay.
So there are two scientists whose major predictions have never been shown to be wrong.
Right.
And here's an interesting story about one of them.
That's pretty impressive. I love predictions. That's where real science is. There's too many people focused on data.
So about 150 years ago, people were calculating the age of the Earth.
Right.
And it was either Lord Rayleigh or Lord Kelvin, one of the two. I forget who it was.
Okay.
He modeled the Earth as a ball of molten rock and calculated how long it would take to cool down to the surface temperature that it is today.
Okay.
And he came up with some number like in the millions of years.
Right.
And he published that.
Right.
A member of the Royal Society, Charles Darwin, said, impossible. Impossible.
Impossible!
There was not enough time for evolution.
Oh, interesting.
Guess who was right?
Darwin?
Natural radioactivity had not been discovered. That's what heats the Earth.
Oh, okay.
So when Henri Becquerel discovered natural radioactivity, and people realized a lot of stuff is radioactive, and a lot of it's in the Earth, and it's heating the Earth, that's what kept the Earth hotter than it should have been.
So the radioactivity is a missing piece of the equation.
That's right, and
that's what
Darwin was right.
Oh, Darwin was right.
Darwin was right.
Yes, nice. Darwin made some amazing predictions.
Almost none of them have been, all the major ones are correct.
And the funny, so this is exact, I just wrote an article, I have a bunch of scientific theories of my own, and I just wrote an article about the state of science, like a couple months ago, and I used Darwin as my golden child, so I'm really glad to hear that.
So, so in 1905...
You know, so many people take his data and they just, like they'll take a page out of his book and they'll be like, oh, see, this proves that these people are inferior, or these animals are a waste of time or a dead end, and it's like, no, you have to look at the broader theory, which is that we're all one evolutionary tree. That's the real prediction.
Well, I think, and the other point is that the nature of purpose doesn't appear in evolution.
Right.
Evolution occurs because it does, not because of any purpose.
Right.
It's random.
Right.
And
yes, the Cthulhu reigns supreme.
So anyway, and so Einstein in 1905 wrote his papers, and the general relativity paper was among the last. And in it, and I was just telling this story to Tom earlier today, and Logan, who works for us. So he published his papers in 1905, and then like in 1911, this guy is in the foxholes in World War I, and he's calculating cannon trajectories.
Parabolas.
Right. And so, but it's extraordinarily difficult because a simple parabola gives you errors of like a half a mile.
Right.
So
which doesn't kill anyone.
Right.
Just makes a pretty noise, pretty light and loud noise.
Right. So he's calculating trajectories, and in the middle of doing this is the apocryphal story. He calculates he solves Einstein's field equations for the first time ever. They're very difficult to solve, and he's the first one to come up with a solution. And it's easy. You plug the solution into the equation, and you check them.
Please excuse my French. Get the fuck out of here! I didn't know that.
Yeah. So
in the trenches in World War I.
Yeah,
Talking about working under pressure.
Right. Well, yeah.
What was his name again?
His name is Schwarzschild.
Schwarzschild. Okay.
And Alfred.
Yeah.
Steve, you can look it up.
Google it. I'll Google it. It's fine.
Schwarzschild radius.
Google it, people. You all have to Google it.
Schwarzschild radius. So he calculates the first solutions to Einstein's field equations, and he discovers that there's at one certain point of gravitational attraction, there's an infinity. And Einstein looks at it and says, well, there's no such thing. It can't be. Nature will find a way out of it. And 100 years later, nature didn't find a way out of it. There it is.
Carl Schwarzschild?
Yes.
All right. Thank you.
So,
with a K.
Right, with a K. And so that radius is the radius you see in the picture.
Oh.
And since then, there have been several other solutions to Einstein's equations. But
So
also,
what exactly are people seeing with the light versus the darkness in the center, which I assume is the
So
singularity?
what you're looking at is essentially the brim of a hat.
Mm-hmm.
It's you're looking at as if you were looking at the top of a hat.
Mm-hmm.
So the black hole is the crown, and the brim is the
I'm
glowing
familiar
ring.
with the model where the gravity wells create
Right, so-
dip into another
Right, but what you're
into
looking
a third
at,
dimension.
Right, but what you're looking at there is that well, as if you remember, you know that carnival game where you roll a penny down a funnel.
Yep.
Where you're looking at that well, what you're looking at is the pennies rolling around the outside. That's what the glowing ring is.
That's why the concentration of light on the outside.
Right, and it's slightly tilted so that the bright spot is closer to the Earth.
Oh, that's why we couldn't see it till now, because it was tilted to us.
No, it's slightly tilted. That's why one side is brighter than the other.
Oh, okay. Why couldn't we see it till now? What happened? What
It's
changed?
very, very far away.
It's very dim.
It's very, 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 very,
They had to
very
take a
far.
lot of pictures and make a composite, and
They took a lot of telescopes. The telescope is the size of the Earth.
right,
They use many, many telescopes.
right.
And they connect them all with atomic clocks.
Right.
And they synchronize the images using
Right.
the clock timestamps. And the amount of data was so large from the observing sessions that they couldn't use the internet to send it to MIT, so they were actually delivered in hard drives.
Ethernet. Oh, nice. Okay.
Yeah, they're delivered to hard
just like Amazon. No, sorry. Not picking on the cloud. Anyway.
And and we have to give a shout out to the woman postdoc that wrote the routine to put the images together. I don't know her name, but Tom Canino, my CTO, told me that it was a woman postdoc. They interviewed her. But
Nice.
it's a vindication. I don't think they're going to get a Nobel Prize because the colliding black holes were the proof of black holes, and those guys got the Nobel Prize.
Right. So it's not a proof, but it's another verification.
It's an observational proof.
Right.
But it's a direct
And it was a
observation.
prediction.
It's a direct observation. The colliding black holes are indirect